second example of a transformation from its parent function. The next parent function that we're going to talk about is f of x equals the square root of x. If you remember the shape of this graph goes off to the right, looking like a half of a parabola. All right, so what we want to do is identify what are the transformations that exist in this red new function. So let's identify this first piece, the negative. What does the negative do to our function? So the negative is in front of the function. So let's go back to our purple slide. When you have a negative, you're going to have a reflection. So if I go down to the red, the negative is in front, so we're going to reflect about the x-axis. So the rule is reflect about the x-axis. So if you think about our parent function, I'm just drawing a quick sketch. Here is our parent function, and here is our x-axis. We're going to flip it. So what number is changing? Is it the x values or the y values? In this case, it's all the y values. They're flipping signs. They're going from a positive to a negative or vice versa. So when we write our rule, we have our original order pair, x, y. What happens is you're going to change every y value to the opposite sign. So you're negating or opposite signing the y values. All right, the second piece is a multiplier of 4. This is in front of the function also, and it's a number greater than 1. So if we come back to our first slide, we're going to scroll down to the green section. Here is our A. It is greater than 1. So what we say is a vertical stretch by 4. So the verbal is a vertical stretch by 4. So how that affects our shape is it's going to take that blue parent function and stretch it up 4 times the original amount. And what it's changing is it's changing every y value. So I'm going to go ahead and throw a 4. It's kind of looking kind of messy there. There's the negative. I'm going to multiply every y value by 4. Because we're switching it vertically. Vertical is always the y values. All right, let's go ahead and now graph this parent function, the absolute or the square root of x. So f of x equals the square root of x. We have these same 5 original x values that we used on the previous example. We're going to evaluate the function. So we're going to substitute -2 in for x. You can't have a negative square root, so that does not exist. I'm just going to put a line through it. Square root of -1 also does not exist. It's considered imaginary, so it does not exist. The square root of 0 is 0. The square root of 1 is 1. The square root of 2 is approximately 1.4. All right, we've already graphed that parent function on a previous video. So let's go ahead and graph this now. So we're going to start at 0, 0, 1, 1, 2, 1.4. So there is our graph of our parent function. Now we're going to graph the second function, which is our new function, our g of x in red, and we want to use the rule. And here is our rule. We want to negate the y, So everything in the y column is going to be the opposite sign. And we're going to multiply all the y values by 4. We're stretching it up. We're vertically stretching it by 4. Again, I squished that too much here for you. So negative, and then 4. All right. So we did not change any of the x values. So all of my x values are going to stay as they are. So negative 2, negative 1, 0, 1, and 2. Nothing has changed. Now let's go ahead and multiply all of this column by negative 4y. So we're taking this column. So 0 times negative 4 doesn't exist. And then going to the second column, doesn't exist times negative 4, it still doesn't exist. Go to the third column, 0 times negative 4 doesn't work, it's just a 0. And then 1. 1 times negative 4 is negative 4. And then 1.4 times negative 4. Come down here. 16, carry the 1. Negative 5.6 is our number there. All right, so let's go ahead and graph these ordered pairs. So negative 2 does not exist. Negative 1 does not exist. 0, 0. So there's our first order pair. Still the same as the other one. And then over 1, down 4. And then over 2, down negative 5.6. All right, so we've taken care of now graphing our new function for g of x. We've reflected it above the x-axis, and we've also vertically stretched it by 4 units. Our domain. Here is our domain. It has to start at 0 and greater than or equal to 0. And then our range is below that x-axis, so it has to be less than or equal to 0.